dignitaries, DDs, GDs, and my all dear colleagues. Very good morning to everyone, and thank you for starting the day with us, for being the part of this IRoC 2025. It's truly my privilege to speak on behalf of the organizing team and share a brief overview of how this IRoC 2025 has been structured and how far we have come in this remarkable journey. IRoC 2025 challenge was officially announced on 20th November of 2024, marking the beginning of what has been an inspiring journey. Just a week later, the preliminary round commenced in December, and from that moment on, we witnessed an overwhelming wave of enthusiasm and participation from the institutions across the country. It's a great honor to stand before you and behalf of the Apex Organizing Committee to share how IRoC 2025 has been meticulously structured and the incredible progress we have made. To ensure the flawless execution across its various components, we have formed 6 specialized committees, each tasked with vital areas of responsibility. The Evaluation Committee, overseeing all the round of assessment, area design and construction, crafting the space where the innovation comes alive, transport, ensuring seamless mobility and logistics, catering and food arrangement, taking care of everyone's energy and comfort, event branding, shaping the visual identity of the challenge, and finally the expert panel responsible for the technical reviews in the final round. Each of these teams played a crucial role in the professional and effective conduct of IRoC 2025, and we extend our deepest gratitude to every member who contributed behind the scene. Now, let us reflect the major milestone of this journey. The preliminary round kicked off on December 2024. Later, with the qualification round began on 29th January 2025. The elimination round was launched on 7th May 2025, and the final field round commenced on 12th July 2025, currently underway right here at URSC Bengaluru. This journey was not about the dates, but about the spirit of the competition and innovations. In terms of participation, we saw 222 teams registered of the preliminary round. 177 teams advanced to the qualification round, and after rigorous evaluation, 37 teams moved forward to the elimination round. And finally, we proudly welcome 16 top performing teams to the final round being hosted today. We also recognize and appreciate the commitment of all the teams who participated at various stages. Even those who did not make its final contributed into the finals, they contributed tremendously and to the collective learning and the evaluation of this challenge. Their effort, curiosity, and perseverance are what makes the IRoC not just a competition, but a platform for the growth. It has been deeply rewarding. It has been a deeply rewarding experience for the entire organizing team. To all our finalist team, we salute your achievements and we wish you success in the upcoming field trials and evaluation. Thank you once again to everyone who made IRoC U 2025 possible. Let us continue to shape the future together. Thank you.
Thank you, sir, for your kind words.
Now, I request our respected Director URSC to please come to the dais and address the gathering.
Thank you, Namrata. Good morning. Welcome to all the students to Bangalore and as an extension of our URSC Satellite Center to this Mangaladama function hall. So as already the previous speakers have mentioned to you, you are one of the 16 teams who have qualified for the final field round for this challenge. For that, first let me congratulate every one of you for reaching this. Beyond this point, whether you end up as 1, 2, 3 or N, doesn't matter. All of you are in this stage itself is a indication that you are all winners. So you can be very, very proud of what you have achieved during the past 6 months or so. At least for 6 months you have been working on this project. And just the very thought of nearly the 270 teams who have taken the initiative to participate in this challenge itself is a great achievement, because this is not going to give you any additional credits in your college examinations, and this is also not going to ensure you, when you finish your course, your campus interview will give you a plum posting. That is also not assured. But what it could have done, I hope it has done among all of you, is to infuse a sense of confidence to yourself that you are capable of doing something on your own and achieve something which is not reproducing, which is already done by somebody, reproducing it. Something other than that you are able to conceive and demonstrate it. That is what this confidence, once it comes, it can do a world of wonder for your future life, both professionally as well as personally. Generally, if you see, India is still a developing country, isn't it? But if you see around the world, most tech organizations, private or government, most of the technology organizations are manned by a large number of Indians. Many people are at the top of the organizations, managing many of these organizations. These companies produce and deliver new innovative products and services to the consumption of the entire world. But why India is not able to do this? Indians only are going there and doing the work. Many of the companies, even the CEOs are Indians. But why Indians are not able to do this in India? This is our burning problem for our country. It is a very clear indication that there is no dearth of talent or abilities in our country. People are having sufficient knowledge, talent, and abilities. Somehow, we are not able to convert that ability into monetizable quantity as a product or service. And another observation around the world, if you see, most of these tech companies where we are Indians are at the top position, mostly they are all managers. They are not the owners, or they are not the original idea creators, those who have created an original new idea and that was converted into a product or service which made the company to grow and monetize it. That also, if you see, mostly our people are managers. It means we are all good at managing things for somebody. We are not able to come up with new things, new ideas, new products, new services. If you think about this, you will understand there is a problem of confidence among our people, because we are basically very low-key, short on confidence, and worried about failures. This is, I don't know, at least till my generation, okay, I do not want to put this stigma on all of you. Let us say at least up to my generation, we are all like this. We are mostly like this. Very, very few people are able to rise above this and make a mark, make a change in their own lives, which in turn will affect the entire society. So the thought was that if we are able to somehow infuse little confidence amongst our student community when they are still students, because after you become an employee of a company or your own start some business, at that point the pressures of failure or losses due to some adventurous ideas are too high. So it is the student phase is the time in which people are not too much worried about failure. People are not worried about how much loss it will end up if it doesn't succeed. So that is why we thought that at the stage of students, we should somehow come out with a scheme where at least some 100 people should get little more confidence than what normally people are having. Our thought process of creating this IRoC U, in fact, the name itself we coined such that it conveys the meaning that you are all are going to rock us. That is what it means. You are going to. This confidence we want all of you to gain, and out of the 2,500 or 3,000 odd students who have taken the initiative to get into this contest, even 5% or 1% of the people, if you had got little more confidence and the ability, our belief in our abilities, that is the main problem. It is like all of you have read or heard Ramayana. So Ramayana, in this, Hanuman was like a child, playful child. But the Hanuman was not having confidence that he can go to Lanka and find Sita where she is. That confidence was given to Hanuman by Jambavan. So we are trying to do the job of Jambavan to all of you, that we are trying to show the mirror to you so that you are capable of doing many things. You are the embodiment of talent, courage, and hard work. This is what we want to show you. As an organization, we have our own jobs to do, our own things to do. Our hands are obviously full. But still, this initiative has been taken so seriously by my team here that they don't have anything return coming out of this by doing this. And they are spending nearly every year 8-9 months, so much time, and senior people who have even superannuated from service are getting involved and trying to mentor and help the student community to come out trumps on this challenge. So this is what we want you to get inspired with, that it is not always about what we get in return immediately. The return will come over a period of time. The benefits will be seen over a long period of time, and I hope that this IRoC U challenge also will get fully institutionalized, it not depending upon one or two people who will have to push it every year to happen. It has to get fully institutionalized, and it has to happen every year, and it has to become bigger and more creative, and more students should get engaged, and our people should be finding it so difficult to do themselves. They have to take the services of some event managers to do this. I wish that is what it has to happen for the IRoC U in future. This is from our side, and from the student side. In fact, I would love to get suggestions for what should be the next year or the next year's challenge. Unless this participatory involvement by everybody included in this, it should not happen like one person or 10 persons or only URSC thinking about this and doing it is not going to give us the benefit. Everybody else who have a stake in this, we all want many people, many colleges and students to come us and flood us with the requests for doing this in their place, different challenges, why only once in a year. This kind of involvement is what we are looking at. And this is only one small, very, very low-key event we are talking about. And we wish that this idea gets caught up by other organizations of our nation also, because like us, there are many people around the country. It is not that ISRO only is doing great job. No, it is not like that. ISRO gets good public attention, or the public relation of ISRO is good, and people's the work what we do is glamorous. That is why people get very excited by whatever we do. But like that, around the country, lot of organizations do great work. I wish that like this, many such organizations also get involved in this kind of student programs, so that there should be so many such events happening around the country, that it is not just only these 2,000 students or 3,000 students in this event. It should be some 2 million or 20 million students should get involved every year. That is the kind of movement we are expecting this has to happen. If that happens, I am sure that we don't need to worry about the future of our country. And we are all, most of us, we are all very tired of being referred to as still a developing country, as a leader of the global south. Not really very flattering, isn't it? It is still, it is really not so good for us to be called as still a developing country, even after nearly 80 years of independence. It is time for us that we move out of this. This cannot happen only by people making money. Money alone will not make our country a developed country. The country can become developed country only when its children and students, the youth of this country, when they gain knowledge, along with knowledge, skill, and display the confidence. All this will happen when opportunity is provided for the students to cultivate these attributes and demonstrate their abilities. So we wish that this becomes a larger movement and many people get involved and becomes a bigger event in the future. And as far as the students of the 16 teams, in fact, I must tell you that as per the original plan, we were supposed to shortlist only 10 teams. Last time, only 10 teams were shortlisted. This time, the evaluators felt that the remaining 6 teams after the 10 also have done sufficient work and they have shown their potential. So it will be really unfair if we don't give them an opportunity to demonstrate their skills in the final field round. So we all agreed that it is the right thing to do to allow that another 6 teams also to come and participate. That is why today we had to start at 8 o'clock. Otherwise, we could have peacefully started at 10 o'clock and finished by tomorrow morning. So we are looking forward to your display of your prowess, and that you are ready to challenge the world with your abilities and knowledge. Wishing all of you all the very best for your future, both in personal and professional lives. Confidence should not become overconfidence. Confidence is the one which drives the world. Those who are confident will try to find, in fact, there is a saying, luck favors the brave. So there is the braveness that will come only from the background of knowledge and the demonstrated ability of the person. Then only that courage will come. Knowledge alone is not sufficient. That knowledge should be somewhere shown, demonstrated, not for anybody else, for yourself. For you to gain confidence, you have to at some point win somewhere. Demonstrate that I can do this. That is what this is all about. This is not for the first or second or third prize. This is that you are one among that through 270 students groups in this country. that thought or the top 16 among the 270 groups, that thought should give you sufficient confidence for your future life. All the very best to all of you, and happy flying. Thank you.
Thank you, sir, for your inspirational words.
As we conclude the ceremony, let us remember this event is not merely about drones or rankings, as rightly said by Director Sir. It is about possibility, about learning, and about lighting that first spark in the minds of tomorrow's scientists. To all the teams preparing to enter the final round, we wish you skillful flights, clear code, smooth landings, and lasting memories.
Now, we request our Director URSC to officially announce the commencement of the final round of IRoC U 2025 and to please open the arena.
So I had only say, that's all. We'll go there. Okay, it gives me great pleasure to announce that the final field round of IRoC U 2025 is open now, and we will symbolically open by cutting the ribbon over there. Yes.
Students, come. Come. Come, come.
Make the next year challenge ready.
Oh, yes, yes.
there's a small announcement. Participating students who have still not had their breakfast, kindly go to the ground floor. This is a request again. Students who have not had their breakfast, kindly go to the ground floor. Please have your breakfast and come. To all the other dignitaries, URSC employees, high tea is arranged in the ground floor. Kindly go and make use of it. Thank you.
You can have judgment, and total marks are 45. Explain. Okay, sir. Sure, sir. Yes, you can have judgment, and total marks are 45.
No, you are asking them to scan. What I just want to know is, after they scan, are they supposed to show you something like this?
Explain. Okay, sure, sir. Yes, you can have judgment.
Correct. No, that means
That
who is going to
laptop-
evaluate this? Will you be able to evaluate this scanning thing?
Sir, they will be showing the telemetry and the topology on the
We
screens.
will come to know. Now, how we will come to know that?
They will show on the screen, sir.
Show on the screen is what?
They will show on the screen, or they will tell us what are the coordinates they have found
Units,
relatively.
because you have written in feet here.
We don't know exactly in which.
No, some of the units are little, I don't know.
So basically,
Some are
sir,
in mm.
yeah, for this one, sir, regarding
feet, I
the
think.
actual coordinate location will be shown in the telemetry. The actual visualization may not be available online. So in the offline mode, they can actually show us what map they have created.
So what?
Yes, sir.
So what is this unit here? Oh, this is in meters. Yeah. Meters. Okay.
This one, sir, 4 meter by.
ಅಲ್ಲ ಇಲ್ಲಿ ಮೀಟರ್ ಇಲ್ಲಿ 4.8
Saurabh is here only. It is in boundary, sir. If it is in boundary anywhere, if it as the as you also that is also 40 marks. If it is like just exceeding the boundary, then appropriately that by fraction we can. Because sir, exactly because actually what happens is navigation algorithm will pick some points based on the variation on the map. So it will exactly not pick the second also. So it may pick little on the boundary, so they will land on the boundary. Sir, the drone is actually less than 50 meters short. So 1:4 kind of. So more than 1:5 is there. Actually, this is much bigger than what they had in their own trial rounds. They had a much smaller thing.
Number of attempts. Hello. Sir, one more thing. For evaluation marks, the rightmost top eval marks 1, 2, 3 Roman numbers are there. Those columns are for re-attempting if they are doing, and if they are getting more marks, yes, they can be allowed. If they are restarting in the second attempt and if they are performing better, they can be that can be considered. So for that we have given first attempt, second attempt, third attempt. Any more attempts, I think we have to write behind or somewhere, sir. We will give one more sheet. It can be requested.
Just sir, just this
Yes,
bonus
yes. As
marks
the
will
gap
come
is
down.
there, you can add.
These
In case
marks they don't get
not,
as
then we
much as
will get
marks
one
they
more
got
sheet
in
for
the
that.
3 attempts. But here the bonus marks will come down actually. So in the first attempt only they are doing, the bonus mark is 6. But in the second attempt the bonus
Not
2
that
marks
way,
will
sir.
be there.
Autonomous
That will be 4
only we
only.
are allowing. Autonomous only we are allowing all the attempts. So autonomous in the sense end to end they have to do. Yes. So if they are doing anything in break
20 minutes
piece,
the battery can sustain. 20 minutes battery can sustain, sir.
nearly,
Fully
sir.
charged battery.
For
You can use
individual
for
teams it
20
will
minutes only.
changes. Yeah. Sir, in the we have given the top team list. In that they have given their features. So when they come, you can just go through that. This is the one, sir. Yes, sir. Yes, sir. Sir. That will be considered, sir.
That will be considered.
Because they have done that autonomously completely. Only for bonus marks of that number of attempts second, that alone will be cut. But this entire execution they have performed. Yes, sir. Yes, sir. Yes, sir. Yes.
But we will decide only in sir.
Yes, sir. Only bonus marks will change for the number of attempts.
But we one thing we have to decide that among this only bonus attempts, not like list of various attempts.
Bonus marks will be given here.
No. So here some. Whichever is maximum that will be.
Yes, yes. Sir. Now we will announce, sir. Saurabh. Okay, I will get the teams.
So your leader is ready. That other day she told actually she अरे यार वो crisis में लेके आते तो हाँ हाँ yes so they are bringing to RSL to test that now they are I think breakthrough
Rest of the teams can leave,
the
please.
detectors also yeah it is getting but he got one few detectors he got see what he is the thing is that he is getting more marks with 40
You are from this one.
We have some catalog or who is the next team who is performing. If that is available, we can put as a PPT. So what I request is, because today, tomorrow, 2 days event is there, you ask somebody to prepare a PPT, one team. So next will be.
Sir, can you once contact Nikhil? Nikhil? Here, Nikhil. That team-wise, time-wise, slot can be, somebody can make a PPT.
If there is one slide.
Sir, the papers are flying. I think some switch yes, sir, yes, sir. Some more fans are kept. Okay, okay. Already 40 minutes.
Which college first? Okay. That's what I asked. Hello, so, Temple. So the DD I told that you and Bhagavan take care that budget meeting.
Shravan, we need to ask. You can.
Okay. You take care that this one. And DD is the main chairman for this evaluation committee. You take care that any no concern no. Do you have any concern? Huh? No concern. Then okay no. Anything is there okay no problem. You tell that IRoC talk with them. No? They are all in that. Tell okay no problem. Inauguration అయిపోయిందన్న నేను ఇంకా లేట్ వస్తాను
How all components have arrived? You are ready? So I can declare? Okay. Anyway, so I'll declare team 1.
And you have to select it.
So, good morning all. So now the first team is team Astra. We are starting at 9:35. They are from Indian Institute of Information Technology, Design and Manufacturing from Kanchipuram.
Yeah. Good morning, everyone. Our expert panel is here. I am part of the expert panel, and our esteemed colleagues are there, and our senior members are there who will be evaluating your actual challenge. So I hope you are aware of, your team is aware of all the requirements, and And this is first you may have to select home position and heading position among 5 possible cases. You may have to select one of them. They will immediately arrange the home position there. And from there you are supposed to
We are going to go, will we scan whole arena so that we can generate the map. Once we'll be having the map, using the flat surface detection algorithm, we'll be finding the wherever the flat surface are there in the map.
you don't have a problem in the heading. Heading, okay, anyway, you selected, Sairam? Sir? He has selected the spot position, home spot 2, and heading towards north.
Okay.
So probably,
CNMG?
just check. I'll put it back in. Maybe.
Home spot 2.
Home spot 2 and north heading. So in case you have difficulty, you can, no problem. Just attempt that. Okay, that's it. There should not be a problem.
Approximately.
Yes, sir, yes.
So we can start the Q&A also in case if the time is there. Your configuration of the this one you can say what type of configuration of your system? System configuration.
Yeah, sir. Our AVNE, the weight is under 2 kg. So the flight, we will be using the optical flow sensor
Weighing
for
scale.
the navigation.
Saurabh, weighing scale.
Optical flow sensor for the range, for the altitude measurement, as well as the sensor, inter-real sense camera for the X and Y for getting. After that, The flight time of the drone is like 13 minutes with 8000 mAh battery, and the drone is like the kit we have bought from the other shelf, but some modifications we have done. Like this is we have designed our custom Jetson mount by ourselves, camera mount, battery placeholder, and the landing gear from ourselves. So.
Yeah.
Yes, sir.
What is
Yes, sir. First, we will be doing the simultaneous localization and the mapping. So we will be generating the map of whole arena. So using the stereo camera will be facing the downward side. So it's like a stereo camera, depth camera. So it will generate the depth map. Point cloud data will be getting continuously. So once we'll be having the map, uh, will be getting receiving this map, and on this map will be applying our DB algorithm, so that wherever the flat surfaces are there, the even surfaces, it will detect or whatever the width is there, 5 cross 5 feet, and it will land over there.
So you also, the periphery identification also is part of your task. You will be able to identify this periphery because that is colored specifically for that purpose.
Yes, sir. We
You
will
will be
detect the
able to.
flat surfaces only. Flat surfaces we can detect
Flat surface.
without any.
Okay.
Now, which are the sensors you are using to do this task total?
Yes, sir. So we are using Pixoc flight controller in that inbuilt gyro scroll, accelerometer, barometer, and the magnetometer are there. External sensors are the optical flow sensor with a rangefinder. So optical flow sensor give the X and Y, and the rangefinder will give the altitude. So optical flow sensor will be using.
Okay. Now,
And the
to check this boulder, what is the size you have taken? How much size it will detect?
detect so 5 to
Boulders, boulders. Here, so many obstacles are there. No?
Yeah. So for that, in the threat detection algorithm, we have set the threshold. Okay, it like in 0.9 threshold, like how many like obstacles are there, so we can avoid, and we can detect there. So, yes, sir.
When it is coming down and when it is about to land, what is the scheme that you have used?
Sir, first it is detecting the hotspot. Once the hotspot is, if it is finding, we'll be using the ROS 2, okay, for the navigation purpose. ROS 2 with Ardo pilot firmware. So our ROS 2 node will be running.
It'll keep it away from your. Yeah.
So our ROS node will be running continuously. In that we have implemented our navigation algorithm. So first it will start from the home position. It will scan the whole arena.
I'm asking you how, when you are landing, what is the scheme that you are using? How do you navigate to your ground?
So yeah, once we have received all the safe spot coordinates, we will be passing this coordinate in the form of array to our navigation node, and will be going to this all nodes to their hotspots, and we'll be landing over there. We'll be using the landing command for the landing over there.
Further details, what do you mean by landing command means? Say suppose you are at 10 meters, you are at 2 meters, you are at 3 meters.
Yes, sir.
How do you navigate to the, that means how frequently you are going to measure the height? Is there anything like that?
Yeah, sir. The height estimation will be getting from the optical flow sensor in the QGC ground control station. So continuously the height measurement, we have set the 3 meter maximum height. We won't be going the above 3 meter. So our drone will be at the same altitude. This altitude will ensure by our optical from camera, as well as the code which we have written in drone.
Abhishek, just about
manually on hotspots also. But the
manually.
coordinates will be receiving there because some hardware issue is there
Fine.
yesterday.
Okay. Go ahead with that. And you will be able to land on the 15-degree slope as well, isn't it?
Yeah, sir.
There
We'll
should be.
try.
And there are two more tasks for you that you may have to demonstrate the link failure and battery emergency.
Battery fails.
It's possible.
Data.
You will be able to do that.
So data link loss if the drone goes out of arena.
Okay.
So if telemetry loss is there, so for that it will be risky. But battery fail safe will try to.
Okay, you can decide because that doesn't
Yes.
carry a much. You can decide on that. Okay. So you also have 3 attempts. You will try to do in the first attempt, I hope. It's okay. Anything.
We'll
You can
try.
take any
Yes, sir.
3 attempts. Not a problem. You have 45 minutes time.
Yes,
If it
sir.
is set up, we can proceed with that.
Yes,
Huh?
sir.
Yeah. Any other questions, sir?
Sir, their drone is weighing 2 kg exactly. It can be noted down.
Okay, fine. Okay.
Yes, sir. Thank you, sir. Thank you, sir.
All the best. Take care. No issue there.
Sir, since they cannot connect directly because of Linux, their laptop we are putting to you on the screen. This is a screen where you can see their things.
Their telemetry, sir.
No, it is not working. This is a laptop screen. There, that yellow this one, no? That just that will pull it, sir. We'll pull it, sir.
CNDNG team.
Hold here because I asked them to switch out to DC. Power is going coming.
Yes, yes, yes.
Once it clears, I will tell you. Then they can start.
Sure, sir. Sure.
Shravan.
Change to DG now. No power will not go.
Sorry, I'm not getting you. Tell me. Yeah, tell me. Mustafa, tell me. Okay.
yellow color arena. So coming to the scanning, so after takeoff to the height of 2.3 meters, it will start to scan in the lawnmower pattern. So while scanning, it will the Z2I camera. So already what I have said, Z2I camera, that will generate a 3D map by using some SDKs. So ZSDK called ZSDK. By using that, it will generate some 3D map. So what we have programmed is by scanning the arena, we have divided the arena, which is 12 meter cross 9 meter. We have divided the arena into the 432 grid cells, where each grid cell is 50 centimeter cross 50 centimeter. So this side 24 and that side in 24 meter, sorry, in 12 meter scale, there will be 24 grids, and in 9 meter scale, it will be 18 grid cells. So totally 432 grid cells will be there. We have divided the arena into 432 grid cells, which is where each grid cell is 50 centimeter cross 50 centimeter. So we have give the conditions for safe spot, and I have gave the condition for hazardous zone and flat zone and grouped flat zones. So what is the hazardous zone means? Like based on the rule book, they have given conditions like height will be lesser than or equal to 1.5. Sorry, height will be greater than 1.5 meter and lesser than or equal to 2.5 meters. So I have given that also, and the terrain, the hazardous zone will contains many obstacles, and that will be not a flat zone. So that grid cells will be displayed in red color. And again, the flat zones which doesn't have any obstacles, that will be displayed in green color. So in that 2D map, which is divided into 432 grid cells, hazardous zone will be displayed in red color, and flat zones will be displayed in green color. And then the grouped flat zones, which are identified as safe spot. Like our safe spot is 5 feet cross 5 feet. So converting it into meters, it is around like 1.5 meter cross 1.5 meter. So it will consist of 3 cross 3 grid cells. So 3 cross 3 grid cells. So the grouped grid cells will appear in blue color. So this is how we have coded. So the groups, after identifying a grouped flat zones, it will send the coordinates to Pixark. So this coordinates will be in the format of E and U, east, north, up, and Pixark doesn't accept that. And for Pixark, it will take NED format, NED coordinates, that is north, east, down format. So that will be changed into NED format and sent to Pixark. After sending to Pixark's mode is converted into RTL, return to land mode, and after that it will land to the system.
Okay, very good. You have to pick one spot and the heading. Yes, choose one.
You explained how you are going to Hello? Yeah, you explained how you are going to identify the safe zone. Now, after you take off, and you told in a lawnmower fashion you are going to scan
Lawnmower
it.
pattern, yeah.
Okay. Now, when the whole thing is being computed, is it still hovering or what?
Sir, whole thing.
No, you have got to compute the safe zone in this entire area.
Yeah.
Will it still be hovering there, or as it is moving, it computes the safe zone?
As it is moving, it will compute.
Okay, that means after the entire scan, you're going to identify the safe zones and you're going to land
Yeah.
them. So by the time it completes the last scanning, it would have identified the safe zones.
Yes. So after that, it will sorry, the mode is transferred into RTL. So then Pixar will return to.
Okay, fine.
Okay, you are ready with the demonstration?
Yes.
You can proceed. Okay.
So first we are going to try manually and semi-automatic and then autonomous. Yes. Journeys. Journeys Keba Ebenezer.
Zernes,
Yes,
I
sir.
have one question.
Yes, sir.
So your flying machine is having certain weight.
Sir?
Certain weight.
Yeah.
And it generates some lift also.
Yeah.
What is the maximum lift to weight ratio of your machine?
1.5 is to 1.
1.5 is to 1.
Or 2 is to 1.
2 is to 1. 2 times it can lift.
Ah.
Okay. And do you have this? You have integrated. The structure is made by you, or everything is bought out and then
No,
assembled?
sir. We have bought and we have integrated.
You have integrated.
We have bought the Jetson and Pixar from separate websites, and we have integrated it.
Integrated.
There is no available setup. Is not available. We have integrated all three things.
Journalist, first you are going to try automatic or
manually?
Manually, you are going to lift from here, and that scanning you will do manually or automatic?
Sir, that will be given in laptop, sir.
Okay, okay. And then you will demonstrate the green and red zones in the
Yeah.
laptop. That's what is first you're going to demonstrate. Okay.
1 minute.
Good, please.
Timing will start now. You're ready? Okay, when you're ready, you click.
Okay, anyway, we'll note it and then this one, please. You can start. After that, you can ask for whatever. Using the share screen for all documents. Yeah. See, it's even if it's able to show the green and red zones, good. Okay. Sir, even in that case, the hovering part only that will scanning the algorithm. Okay, okay. Right, right. We'll note it, sir. Even at that. That's okay. Yeah, ISRC. Yeah. What number that is available.
One screen, this screen. Other one, that one. Both cannot be same. One has to be a drone. Sir, one will put drone screen, one will put laptop screen. Is that okay so that both can be seen? This is getting webcast or recording?
processor board battery is down, but that's what he's telling. So, yeah, because either they have to keep the charging nearby, so they'll go and come back. I think we have to call the next team.
Give a chance to them. Yes.
Let them straight go for demo.
Okay, Team Astra is about to start. Yeah. So your time starts now.
Extra slow, don't worry. Slowly. Should not break. Should not break. The flatness, any problem is there? I don't know. May not be. Huh? Huh? May not be problem if it is.
Venu, can you keep in center? Yeah, yeah, that's fine.
Should be
Yeah,
okay. Ama, it should be
yeah,
okay.
yeah.
No,
Good.
Oh, ಇದೇ manual. One of them is not genetic same as something.
First time I didn't observe. Now I felt one was not rotating.
Venu, Venu, the landing gears,
First hotspot.
One fan is not rotating.
Land it here, land it here. Then, no, proper hotspot, proper hotspot.
team, you can declare whether you are doing in autonomous mode or manual mode. You have given a mic. You have to tell whether you are doing in using RC or autonomous mode.
So we are using RC to command this.
So it is completely manual.
Yes, this is completely manual.
Yeah, the scanning will be done. You are trying to do scanning? Or?
Landing is also manual.
Okay, noted. Okay.
So there is battery fail-safe. Battery voltage is like less than 11.2, so it won't take off again. Again, it will land.
Okay, it has gone into safe mode, is it? Battery safe?
Battery fail-safe.
Okay.
So battery is like below the voltage, whatever the range we have fixed.
So what is the voltage right now?
You
can enter. You'll be able to see there.
So QGC if you have to see. So, sir, first is battery fail-safe. Second fail-safe is we can see here in QGC the potential thrust loss. Okay, because of the battery fail-safe, the thrust there is like difference between the thrust of both the diagonal motors. Then it will also land there. So because it will crash if the thrust dismiss will be there. So it is also activate. Yeah, you can see here. Yeah, here second failsafe is like thrust loss. If the thrust occurrence is there, like if diagonal motor thrust is not same, then it will tilt or it will fall down. So then it will, because of this, it will landing. It is not taking off at a certain height. Yeah. These are. Yes, sir. Yes, sir.
Battery is down or that battery is sufficient?
Not full. So it is like 11 point. Again, we need to check how much voltage there in battery.
Okay. Okay, now.
Yeah, I will check one more.
Yeah, now how much? Okay, you will at least. 9 minutes. Okay. Are they having some more time to do something? Or? Battery is down, is it? Okay. No, you can have it. It's good. No problem. Don't worry about that. It's okay. Very good. Excellent work. Don't worry. So now you decide how much to.
some fail-safe is activating because of that, I think.
Okay, very good, very good.
So,
You want to do something more?
yeah, sir, we want to explain our approach for the friend.
Okay, okay.
that
And then 10 minutes.
Yes, sir.
Abhishek, no? Yes, sir. Now, Abhishek, you can just explain what has happened, and it's excellent work.
Yeah.
Excellent demonstration. You go ahead and explain to the team. Yeah, come. All the team members can come and then just explain the activities. Yeah, please.
So what we were doing basically with manually we'll be launching and we'll be scanning the arena. So after scanning the arena, the flat surface detection code will run and will show the flat surface coordinate, okay? And we'll be landing over there in flat surface manually. It won't be autonomously because of some hardware issue. So that's why, but scanning we didn't complete 100% till there. So whatever the detection is there, the hotspot, once scanning is fully done, then only we'll get the hotspot coordinate. Because of scanning is not fully done, so we didn't get the hotspot coordinates till
You
now.
were able to get the data from the scanning?
Yeah, yeah, yeah.
Huh? You were able to get that?
Can you show that data?
Yeah,
If,
We need to come here.
yes, sir.
Other team members can come. Please
sir.
join all members. Yeah.
The publish hotspot.
You can, yeah, sir, that is also scanning only, scanning part. First hotspot. Yes, sir, scanning was continuously, simultaneously. Yeah, simultaneously. Sir, we will show the coordinates.
So did it scan some data? Just we wanted to see if it had scanned and demonstrated some.
Takeoff, what we landed and we got this. So it also happened there. Takeoff.
Okay. Safe spot mode, it went. Did it identify the spot or no? No, did it identify the spot? No.
These are the points.
Coordinates from the home.
Yeah, from the home. With respect to that as a home, it went.
Okay.
But landing, we did it manually. But
Okay,
these spots are by the survey. So it went.
Okay.
Some images. No, that file will be.
How did it identify that is a safe spot?
Okay, so we can explain our algorithm.
How much meters it traveled, you tell? From this spot it identified, no? It went. The IMU showed this much difference?
No, sir. Sir, this is like just the safe spots. You can see it here.
Okay, we know. Did you output IMUs telling that stuff?
No, sir. This is just the coordinate points we can get.
That's a coordinate from the home, is it?
Yes,
How
coordinate
much
from
is showing? Can you just tell from home?
This is the 8.2 and 10.8.
From the meters, is it?
Sir.
From the home. From the home.
Yes, sir. From the home.
8 is slightly higher.
Safe spot one is 4.2,
Around, sir, from around 5 meters or from home.
4.2 meters.
Yeah, okay. Second, correct. 4.2. That order should come. Other side?
Order we can't get.
No problem. The first spot.
Okay, so the points for where we landed is something we did manually. But because of the scanning, whatever is generated, that is shown here.
Okay.
So where we landed and this point can't match.
No problem. We are looking at from.
We don't know whether it matches.
No, from the home. Scanning.
Yeah.
Whether it has identified the spot is also.
No, from the no, is it?
We'll get the PCD data like as a whole, like the point cloud data, the entire arena from the scanning. We'll get the entire point cloud data from the map. So the order of the points here will not be the same as the order order in which we surveyed. Like when we survey,
Okay.
this is the first safe spot. That won't be the first one here because
Okay,
our
okay.
plane detection code will get the overall data and it will try to publish. So this 1, 2, 3, 4 is not the order of the safe spot.
Okay,
It is
this is
just
four.
arbitrary
This
number.
is four
So
safe
these
spots.
are the number of safe spots that were identified. So they are not in order.
In the first attempt, when it lifted itself, it identified. You are telling.
Or you mean say, if you have completed all scanning, next time when you would have gone, you would have landed to these points exactly?
No, sir. That's what, sir. The landing is done by manual. The landing, what we did is pure.
Understood.
Yes, sir.
First manually you are doing everything,
Yes, sir.
scanning and
Yes,
all,
sir.
you are identifying the entire terrain.
Yes, sir.
Next time,
Yes, sir.
when you are trying,
Yes,
let
sir.
us say you are putting in auto,
Okay.
giving these coordinates,
Okay. Yes, sir.
will it do automatically and then
Yes,
land it
the
there?
code what we wrote is we'll publish this to the automatic autonomous code, and this will try to survey all this safe spot.
Okay. I think first they will map, then only they will activate these points. At that time it will happen. That's what they are doing.
You're having some 4 lines there, no?
Yes, sir. 4 points.
4 points.
Yes, sir.
All those 4 points are very close to that? All are different, but from there it looks like only that is the safe zone, no? You haven't come till here, so how you are getting 4 points?
Arbitrarily they are going around, they are mapping. Correct. After mapping and understanding the terrain, next time they will feed these coordinates whatever we wanted, whatever the coordinates say point 1, x comma y. They will put it, and then next time if they are successful, they would have gone to land at the same points, 1, 2, 3. That's what they are trying to tell. Is that correct?
No, okay, I have a question. Now, using joysticks, you visually seen and moved. How you disprove this? No, 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 I am telling from this joysticks, by seeing this, I can operate the drone so that it can move. How you disprove this?
Sir, actually, what we done is we manually manual takeoff by seeing only the safe spot. The mapping.
No, I am telling you are not identified space spot.
Okay.
I know where to move. Simply using joysticks, I have moved.
Yes, sir. Now
Have you done like that, or that's what?
The question is, the landing and taking off was manual, correct? By controlling the joystick only you did.
Everything, whatever the drone did is manual.
Only what sir wanted to ask is,
Yes, sir.
the first attempt was to identify the safe. That it is demonstrating 4.
Yes, yes.
You didn't use that, and you manually went and landed.
Yes,
That's
sir.
what you were trying
That
to
is
say.
what we had done.
Yeah, okay.
Yeah.
My question is, you started from there.
Yes, sir.
Okay, you moved this way.
Yes, sir. We moved this.
Okay, you moved from there to there.
Yes, sir.
To see the terrain, how many safe spots are there?
2 we are seeing.
You have identified that also?
We landed here.
No, that manual.
Mapping at
Fine. Then how come you are getting 4 here?
I guess based on the accuracy of our thing, it might have detected other spots also safe. That
What
is
is your criteria for identifying a safe spot?
The dimensions, sir.
What is the dimension you have taken?
5 cross 5 feet.
What is the unit to unit?
Feet, sir. Feet or
5 feet. Do you think these things are okay? Are you having 5 cross 5 safe zones at 4 places?
And 8 meter, 10 meter also slightly higher. 8 meter and 10 meter also is there. Okay. Okay, Abhishek, really an excellent work you people have done. Very, very nice to see. And coming to this, yeah, tell.
We just want to explain like what is our approach for the plane surface detection. So C has worked on that
right
part.
now we just showed what are the safe spots that got published, though they are not as accurate, but how those safe spots got like generated, like that is by a particular approach.
Right. That's good. You showed.
So basically, when the drone takes off, the field of vision of the camera captures the arena. So based on that, the code will divide the arena into grids, and we can see from the height of the camera. This is a 3D space, so there will be 3D point cloud data. So that it will try to map it into a 2D space. So from 3D points, it converts into a 2D space. And then each point will be evaluated or valid or invalid based on whether it is a flat surface or not. So suppose if you see wherever there are stones or wherever there are undulations, there it will be marked as a like an invalid mark, while the places where there are safe spots will be marked as green. And since there is a place, safe spot, which is tilted at an angle of 15 degrees, we also included a check so that that safe spot is also considered and not just as an undulation but also as a valid safe spot. Now the code will accumulate all these safe spots. So all these black place is all uneven terrain, while these places are safe spots. This is just an image to view, it's not the exact arena. And then we perform something called distance transform. Basically what it does is, it will try to calculate the distance of each point from the nearest non-safe spot. So if suppose that is our safe spot, it will try to calculate the distance of each point in the safe spot, which is farthest, which is its distance from the non-safe spot. Suppose say that stone. And it will try to give the coordinate of the point which is the farthest from the uneven terrain, so that this ensures that the code doesn't give a corner point of the safe spot as a safe landing zone. It is supposed to be in the center. Suppose if it gives in the corner somewhere, like even if you see beside the safe spot also it is a little bit flat, but then there is a stone there. Maybe if the coordinate is just a single point. So if the coordinate generates there, then what will happen is the drone will try landing there and it will clash with the stone. So we perform something called distance transform and peak extraction to ensure that the drone lands in the center of the safe spot.
Okay, very good, excellent. You also had some safety thing triggered, you told, no? What are those safety things?
So some safety features we have put in the QGC. Battery fail-safe. If the battery voltage is below the 11.5, the drone will land there itself if in autonomous mode. So here, like we are doing manual, so that also it was not lifting because below the 11.9. Second is data link loss. Let us say we have disconnected the telemetry from the ground control station. So drone will land there automatically, or if the scanning is not completed, so it will find the nearest hotspot or it will land over there.
You had some differential thrust also you showed.
Yeah, differential thrust. So if the diagonal mortal thrust is not equal, so in the QGC by default one parameter is there, okay? So it won't hover, okay? It will try to land in any of case.
Okay,
So
you had initial problems due to differential thrust, some...
Yeah, while testing, we have faced there only in the main arena many times this.
Okay.
One question here, excuse me. See this, what you have done is that actually that you have manually you have done.
Yes.
During that time, what are the sensors are active? All the sensors are performing, or that is it okay or not okay? Suppose
Yes, sir.
height measurement. You
Yes,
have
sir.
put that barometer, that height related things,
Yes,
and
sir.
the vision sensor is there. How
sir.
much height is come? Whether it is background, you have verified the telemetry that all the height is
Yeah,
proper.
sir. Yeah. So in the QGC itself, live data was showing, so the height was accurate.
No,
The-
but with different sensors, you have seen that both sensors are matching that.
Yeah, exactly.
That only we wanted to see. Other thing is that differential thrust was there.
Yes, sir.
How do you manage that with the differential thrust? Suppose if it is thrust is coming, but your modulation of the speed you have to do. That is
Yeah.
happened. Have you
So
checked that?
in the autonomous mode, generally, if some like due to wind push or something, the thrust will like deflect. That time it will land. But in the manual mode, might be use a pitch or roll or some more thrust we have given. That time the error has activated.
No, your manual mode also. Is it that any algorithms are running? What are the algorithms running? Output of that algorithms?
Yeah, sir. For first the scanning, it was continuously scanning. Yeah.
The scanning map is built up to that point. Map is built.
Map was in Judson only, so we were just receiving the coordinates after the map.
Map is there.
Yeah.
Up to that point, at least that first portion.
Yeah.
And the second portion map we could not see.
Yes, sir.
Okay, that map sometime you can show that whether map is properly it is built or not.
Yes, sir.
Okay, what else other algorithms are running when we are manually moving?
The plane detection algorithm is running so that we can show.
Okay.
Through the plane detection algorithm only, we were able to see the safe spots being published on
Okay.
it. So the algorithm was running on our companion computer, which is Jetson Nano. We were able to see the coordinates, which was the output of that algorithm in our system outside in the.
Now, can you do the autonomous now?
So, some battery issues.
Okay.
Sir, basically,
No, actually on 2 occasions it did not take off only, no, it tilted, toppled. What is the reason?
sir, first one the battery failsafe was activated and the
Just
that
tell again, repeat again.
from the second thing was like what I feel is the optical flow sensor. No, so it is like downward facing. Okay, so position estimation was not that much accurate in the that time.
No, what I didn't understand is when you're operating manually, why it toppled?
So manually in the manual mode also we are not doing fully manually. We are getting the data from the optical flow sensor. So it is for the stable flight it is required. It is not manual mode. It was the loiter mode. In the loiter mode we are getting the data from the optical flow sensor X, Y as well as Z. So this X, Y or Z data optical flow sensor give to the flight controller, or based on that it will take off smoothly. So if we don't use the PCO roll for the takeoff, we just use the thrust. Okay. So other things it will automatically take care of the optical flow sensor itself.
Okay. Okay. Okay.
So actually, what we were doing is we were publishing in XY. We didn't have exact control on the motors. So if there is any issue with the sensor, that's why it was toppling.
When you're operating it manually,
Yeah.
what is it that you are doing?
We were just publishing, so we had thrust, that is Z, we had pitch, that is X, and we had roll, that is Y. So we only had control over all these three. We didn't have control over the RPM of each motors. So if the sensor which is giving me the localization, that is optical flow sensor, if that gives me some junk data, then it will fail. So that was the issue, it was toppling.
Here one question. Okay.
Just
okay. Excellent performance. Excellent. Good. You did a very good job. Yeah. Tell only one. Yeah. Tell.
So basically, this is the place in our campus where when we were
there.
testing our plane detection code, we
Okay.
were able to generate this map.
Okay.
Now the map will be in Jetson. Since we disconnected, we can't retrieve the map
Oh,
now.
it is lost that then it's get powered off. Okay. Okay. Okay.
After we powered it off.
Okay.
So
Okay.
basically the code runs, and this is the what we showed earlier.
This is what the unit meters.
This is in meters, sir, meters. So if you map these points on the point cloud data, if suppose if we were able to retrieve the map from the Jetson, and if we map those points,
You get it done and show. No problem. This is what you have done in your college.
yes, sir.
Eh?
This is the code running, and these were the same code. As you can see, the code was able to perform well in that environment.
Okay. Very
It was
good.
able to detect the safe spots almost accurately.
Thank you, sir.
If you are able to demonstrate that data, you show. Okay. Good. Thank you. Thank you, Team Astra. Okay.
45 is their slot. They come by 11.
Second team is not coming.
No, they're charging.
No problem. I also consider. No problem, sir. Sir, you are this one. And one innovation prize. Next time, I have to create. Total the LIC. You can also, you have a choice to do autonomous or manual, everything, it's left to you. And if you are able to identify the safe spot, is good. You just show whatever is, you can decide what you are going to show also, you explain. And also if you have any choice of the lighting or something, that also you have to tell.
Okay, sure, sir. Understood.
Okay, go ahead. Briefly explain. If you have any constraint on battery, go ahead with the actual.
No, I'll explain first.
Yeah, fine, go ahead.
So, good morning, everyone. My name is Nimish, and I'm the team captain of Galactic Garrets. And I'm representing Pune Institute of Computer Technology from Pune. And this is our drone Swastik. So basically, we are using a noble scanning method where we create a depth map using a 2D LiDAR. And the depth map is of 2.5 dimensional. And for localization, we are using an optical flow sensor. Actually, the optical flow sensor is not a ready-made one. We are using a Raspberry Pi camera, and we are using a self-made algorithm for localization. And talking about the architecture for processing power, we are using a Raspberry Pi 5, and the Wi-Fi transmission for the connectivity between the drone and the base station is done using an ESP, because ESP gives a better bandwidth than Raspberry Pi. So talking about the sensors, we are using a 2D LiDAR. 2D LiDAR scans one line at a time, and it rotates using a servo motor. So basically it scans one rectangle below the drone in one scan. And it takes very less time, and it is also very efficient. Our drone is actually very cost effective, as we are not using any ready-made sensors like depth camera or stereo camera. We are using self-made algorithms and basic sensors like camera and a LiDAR. So the LiDAR will help the drone to scan the arena. It will create data points of XYZ, and it will create a map. Using computer vision algorithms, the map is converted into a depth map, and using algorithms, we are detecting the safe spots of given area. Actually, we want to give you a better explanation about the coding part. So may I please ask my coding lead to join me? Rushikesh.
Automatically you are doing? You are doing automatic?
Yeah.
Hello sir, my name is Rushikesh. I am the coding lead for our team, and I would like to tell you about our novel scanning method. So instead of using the usual depth cameras, which we can get pre-made everywhere, we are using a 2D LiDAR sensor. It captures one slice of our 3D space. So if the way we are orienting it, it is currently vertical. So it will capture a slice in this plane. To get our 2.5D map, we are rotating the LiDAR about an axis along its plane. So it will rotate like this. As it sweeps over the surface, it will get 3D data points, and we will construct these into
the scanning is by what? That scanning will be by?
The scanning will be by a servo.
Servo. Yes. And you don't have a problem in east, I think it will be facing their periphery also, will identify, isn't it?
Yes, it has a range of about 7 by 8 meters centered on the spot of the drone. So we have three strategies to cover the arena. Our first one will be to start from the starting spot and go to a predefined corner. So we have defined a direction which is at 45 degrees to the drone. It will keep moving in that direction until it hits a boundary. Then it will keep moving along the boundary until it hits a corner. So that will be its reference point. And from there, it will go 3.5 meters towards the center, like away from the corner. And then it will start scanning.
Autonomously, you will be able to do,
yes.
isn't it? After you give a start, it should
yes.
suppose. Okay, good. Very good.
No, that movement is only for getting a reference of the arena. The scanning will be like as it gets new spots, it will land on them and then continue scanning.
So the moment you find, how do you identify a safe landing place?
Okay, so once we get the 3D map, we get these data points in 3D space. We convert them into an image for which each pixel corresponds to the height of that point. Then we apply an OpenCV algorithm called variance, by which for each pixel. Okay.
Proceed.
Thank you, sir.
So shall we just continue the explanation? Okay,
Okay,
let's. Okay, sure.
thank you, sir.
Thank you, sir.
As per your
Okay, sir.
And Nimish, the data you are going to show, what you are going to show here, the video or base station you can show? Okay. That can be shown. Okay, they are arranging.
Check.
Go ahead with that.
So, orientation check. Rishikesh? Orientation check.
Actually, there would be two base stations for our case because we have to start the command on terminal on one base station, and all the
RC is on.
telemetry and all the maps would be displayed on the
Aryan,
main base
RC
station.
is on.
So it would be
Unkilled.
thank you.
Okay. He's just
Nimish, you can announce also some. Take a mic and you can just announce the activities. Yeah.
Okay, yes.
Thank you, sir.
Okay. Making run. Started. ठीक है चालेल. ओके ओके. तू फक्त spot detected from here.
So we are increasing the height to 3.5 on the base station.
Now the drone has taken off to 3.5 meters of height. Now it is finding the first corner so that it can have a reference of the arena.
Edge detected. Second edge detected.
All the edges detected.
Okay, okay, kill. Anti-clockwise check progress. Anti-clock.
निमेश डबल साइड में
Not yet. Scanning is not started.
मास्किंग दे मास्किंग
Okay.
we will get another push button. Everything is fine now? Everything is working. प्रत्येक for sure. LiDAR फक्त थोडं हलवून वर. Okay, LiDAR वर. Good, LiDAR वर.
Disturbed in between it seems. So suddenly it added some error to it. So in between there is some loss of data.
मैं बोल दूंगा तीनों ग्राउंड स्टेशन ओरिएंटेशन चेक
Drone bridge.
Raspa is not visible. Drone bridge. ESP is not connected. Orientation check. Battery connected. Nothing is hanging. Okay. Connecting. Ready with RC? Still not coming.
माइक ले माइक कुछ बताना है Excuse me, sir. Actually, one of the connection has broken, so we have to resolder it. So maybe take 10 minutes for that task.
Yeah. If you can complete in 10 minutes, you can go. Otherwise, you can do
Yeah,
it.
sure.
Come
Thank you,
back.
thank you,
Come
sir.
back.
अंतर सोल्डरिंग आला डबल सोल्डरिंग गन ला रहा है
टोटल ESP पहले कार्ड जितना आणि मग सोल्डर कर ESP जितना कार्ड आणि मग सोल्डर कर अभी क्राउड मत करो उसको थोड़ा दूर रखो तब तक ये बैटरी चार्जिंग में लगा के
are they
So it was unable to tell that it had actually moved. So it just kept going in that direction. Yes. Yes. So it was unable to tell its own position. So even if we had put a limit, then yes. Uh, so it is continuously moving here, but suddenly you will see it skips ahead. No, no. See, sir, it skipped. Here we were recording the video, so we think it was because the video was too large and it was spending time writing the video. So we have disabled that now and we're trying it. Okay, sir.
Rishesh, one more doubt there.
Could you just tell what you want to do? Say suppose you identified this corner. Yes. What you are supposed to do? Then we move away from the corner, so that would be 45 degrees like this. We've set it on a distance of 3 meters. So it will move to roughly some central part of the arena and then it will start scanning.
Okay, so from here it goes to the center part of the arena, then it starts scanning.
Yes.
You mean to say from here it can scan the whole this?
So it cannot scan the whole thing, so we don't move it to the exact center. We move it a little short, so one scan can take, let's say, a quarter.
Okay, so you move to some point,
Yes.
then it will scan.
Yes. If it finds a point, it will land there.
And
Scanning, it will find whether it is a safe place or not.
Yes, sir.
If it is a safe place,
Yes.
otherwise it will move further.
Yes. If there are any safe spaces in this area which it has scanned, then it will find them. Not specifically that point, in the region around it.
And also between all the scans there would be overlap
you have
such that
Okay, fine. I got the answer.
you have some
Okay,
options to
continue.
manually abort something, manually stop, and if it goes to unsafe, you just take care.
Yes.
If you have manually, if you can do something, you do it. Don't worry about the full autonomous. Huh? Yeah. And any safety manually you want to do, take care. Okay.
Shashi, you could have 3 attempts in total. We now
sir, so because of this we are making certain changes right now. We are reducing the height of the drone from 3.5 to certain lesser range. And instead of starting it this side, we are aligning the drone to the same position, but we are instead starting in the top left, right now. Actually, height is not the issue, but because of the height, it is hard for us to take manual control. And
Because of the height, it is
it is hard for us to take manual control and safely land it before it crashes.
before it crashes.
Yeah, yeah. So at a safer side, we are taking a lesser height.
Because height shouldn't have really any
Yeah,
issue.
it doesn't have any. At least till 5 meters it doesn't have.
You are using depth camera or you are using stereo vision camera for the depth?
No, neither one.
Huh.
We are using a normal wide angle Raspberry Pi camera module. So it covers all of the things, including the localization. The stereo camera and the depth camera are used for scanning. So we are not using camera at all for scanning. We are using a LiDAR.
LiDAR. And then optical flow sensor also you are not using here.
No.
You are deriving from that. You said you are derived the algorithm from using the
Raspberry Pi camera.
Raspberry Pi.
Yes.
Okay. Thank you.
Thank you.
Nimish, you are ready?
Yes, sir. Yes. Any more doubts?
Good, good.
Thank you.
नहीं ठीक से
हो गया get back remove the baggage
So just making sure one second. This time the drone will not start at this side. It will take the shorter edge from that side. Thank you. Yeah, thank you. हा कोणाचा कोणी दिला ओके ठीक आहे So is this mic of one of the okay I thought it is from one of the judges.
Orientation check. RC is on. Unkilled. Setting height to 2.5 meters.
Also do the level calibration as well.
Okay. Calibrator level. Rebooted.
Okay, ready.
Ready.
Mode change.
So telemetry data is visible here. Okay. Let's start.
Three, start. The drone is arming.
The drone has taken off. So it detected the yellow corner and now it is going to the first scanning spot. Now it has increased its height so that a larger
Scanning.
area can be scanned.
Detected. Correct.
So it is heading towards the first landing spot.
Precise scan.
Now it has reached there and it is taking a precision scan so that it does not land outside the safe spot.
All spots detected, okay?
So there seems to be some technical glitch. It should have landed on that spot, but it seems to be going to the other spots.
So it has also detected the inclined spot, so it is taking a precision scan over that one. It detected the third spot as well, so it is heading there and it is taking a precision scan there. Unfortunately, it is not landing on any of the spots, but it has detected them. We can try to correct it if we want.
If you want to manually control further, you can do it. Okay.
No, not manually.
Or you have to feed semi-autonomous. Okay.
Manually landed, Rushikesh?
No, semi-autonomous you can feed.
Let it land. Let me see. Landed.
can
Actually,
explain what was the...
Detected all the spots, but for some reason
Unfortunately, the code.
Okay.
Just 1 minute. Can you tell what was your role in this?
to make sure that
Sir, we'll show you the image. We'll get the coordinates here.
make sure that it doesn't crash. In case it loses control, I'll just take manual control. Like right now, it refused to land, so I manually landed it. Yeah, I did it because it was supposed to land, but for some reason it didn't. So we'll check the code once. You can explain the image.
Yes,
It
so
detected all the. Yeah.
we'll check what was the error and we'll try again, get it to land. In the final explanation, we'll give all these images that we've captured and explain them. Yes. So wherever we see green spots in
and
this
in
image, those are the
semi-autonomous
safe
mode,
spots.
you can feed the...
And this is the drone position.
One team can correct it, other team can explain what has happened.
Okay, sir. Okay, sir.
Semi-autonomous mode, you can feed the coordinates and land also. No, no. No, manually it did after going there.
Confusion whether it has done or not. Okay, forcefully run. So it will not. I want this coordinates you can feed. That is also I'm telling. Because we had also. Okay, then it would work.
It has to charge in the battery. It has to be charged.
6 minutes only. Oh, very good.
Yes, battery.
This landing was manual. The landing was initiated, but after that it was not controlled. Actually, the drone should have landed on all of the 3 spots after detecting them, but actually probably the landing function was not called or something like that. So we had to land it manually. So we are correcting that issue right now. Yes. Yes, we'll show the maps in 1 second. So this is the first scan which was taken at a higher height, and this scan contains the whole arena. The purple dot here denotes the position of the drone, and these 3 green dots denote the safe detected landing spots. And all those red spots are detected, but they do not match the area constraint of the safe spot or the aspect ratio of the safe spot. So they are denied, and only the green ones are the ones which are safe to land. So these were detected. Next scan. Yes, sir. Actually, our algorithm cannot tell the exact angle of the slope. So after a certain incline, it doesn't accept it, but at some angle, it accepts it.
So it
But
is go, no go kind of.
yeah, it is not a
slope.
perfect thing.
Okay, so you cannot tell what was the slope.
Yeah.
You can tell it is more than 15 or less than 15.
No, we cannot tell in degrees what was the slope of that. Yes, this specific spot was sufficient, safe.
It's a grid resolution. That grid resolution, how much is there here?
640 by 480.
480. That
Yeah.
okay. 640 means that 12, this one, that
Yeah,
30
the width.
meters, that way it is.
Yes.
30 feet.
Nimish,
Yes, sir.
which are the sensors which are used in order to generate this map?
To generate this map, only one sensor was used, which was the 2D LiDAR.
2D LiDAR.
Yes. And it scans, it uses a servo to sweep an angle so that it scans a wider range. And using the drone's localization, we know the exact location of the drone with respect to the map.
Show the previous image.
Zoshi, Atharva, previous image, the map. Actually, he is working on that on another PC. So,
Okay, you can explain that. You can explain how you
yes,
are
sir.
doing.
So actually, the main error what happened here was that the precision scans did not detect the safe spots. That's why they didn't land there. So during the precision scans, it got denied. In the main scan, it got accepted.
There are so many polygons there, no?
Yes.
Able to make out. Which is the safe thing? How you have identified the safe one?
Actually, on the depth map, it adds some filters like blur and variance, and it creates this certain map.
Okay, now this, how you are able to identify the safe landing area?
There are a few aspects. The first one is the area. So we have for every height there is a certain area range which is acceptable for the drone to land. Another variable is the aspect ratio, that the area must not be very long. And one more thing.
And one more thing is the variance. So we scan the pixels. If the pixels variance is more, like we'll get the pixels height also in camera, right? So if the spot is flat and the other point means अगर ये flat spot है और ये कुछ नहीं है तो इधर के pixels match नहीं होंगे और उसमें variance होगा तो इसके वजह से वो flat spot detect होगा.
Okay, seeing this image, can you tell which are the safe places?
So the green dots that are there are basically the safe spots.
Meanwhile,
So
just a second.
previously we were using the Laplacian
Whether the
operator for the
boundary-
flatness detection.
yellow
So
boundary,
it was
whether you are
calculating the double derivative of x and y
radar
and then
data.
giving us the radius of curvature. But then now we have switched to this variance method where if we have similar points, they'll have a low variance, and if there is a outlier or something like that, so it's going to be a high variance and that won't be detected as a flat spot. So that's the reason. And green spots would basically mean the safe ones, and the red ones are the ones because of the area constraint and the aspect ratio, we have ignored them. And the purple dot is basically the drone position.
Okay, just one question here. This yellow boundary you are detecting by a different sensor, like a different camera.
No, actually, there were two methods for the boundary detection that we were doing. First, we filter out the HSV range, so we get the yellow color out of it. And what we do is for every yellow pixel, we create a vector that is opposite to it. So it creates a force for the drone to go in the opposite direction. And that way, whatever yellow pixels are there, it'll always create just like the electromagnetic distance kind of logic that is there. So for each distance, there's a corresponding vector that comes in the opposite direction. So it'll move the drone in that direction. This was one method, and the other method that we thought was of using the convex hull method from OpenCV. So this is going to again take the HSV range only, and then there's this inbuilt library of the OpenCV where we use this convex hulls and then convexity defects. So from the yellow pixel, it'll take the deepest point where it finds a concave edge. So that's for the corner part.
So you're not using camera data for detecting?
Yeah, we take the camera feed, and from that only we take the HSV range.
Your LiDAR is scanning. So how good is
LiDAR
the match between camera coordinate and the laser coordinate?
Yeah, so the LiDAR is for the safe spots only, and the yellow color only for the boundary detection. We are using the camera. Yeah, so that's it.
Fine.
Excuse me? How are you identifying the boundaries here? So in that image, no, how are you identifying the boundary?
The yellow boundary or the safe spot
Yeah,
boundary?
yellow one.
Yellow boundary, we are using two methods. One as a fallback one. The first one is to basically take the HSV range for the yellow color, and after we detect the yellow color, for every yellow pixel there is a vector that is created in the opposite direction. So that way it will take the drone in the opposite direction. So it's like an invisible wall.
But is it representing there in the image?
Not in the image,
Not
only
in the
for the
image.
camera
It is algorithm only.
yeah, only by the camera we tell that a corner was detected, and so the drone knows that it has to move away from it. The other fallback mechanism that we had was using OpenCV, where we use this convex hull and convexity defects functions. So it takes the deepest point for the corner, and then over there it sees that there is a concave kind of a shape detected, so that means it's a corner.
Which one it has used here?
Currently we are using the vector one. Yeah.
So in vector, if the drone is away from the yellow boundary, so the vector would be small. But if the drone is near to the boundary, then the vector would be large. That is, it is in the inverse proportion of its length. Matlab, we would know कि drone is far or near to the boundary.
But whether you will get any singularities, suppose if it is just on the boundary, the length will be almost it is 1/0, no?
So for it, matlab, agar if it is near the boundary na, so vector would be more, indicating that the drone is near to boundary. Like you have to move up.
So you were telling about that precision scan thing did not work. So what is the criteria? Like earlier you were able to find the spot, but finally you were not able to land. So what is that? Like, what is the other criteria for landing? Like what?
Precision scan is basically the second verification criteria that we use. So
Yeah.
in the first scan, it did detected as a
Yes,
safe
sir, we
spot.
are ready.
In the precision landing, that time it did not detect it as a safe spot.
No, why means precision landing? What are you checking?
We just verify the safe spots. Like again, we sweep through the scan and we check.
So sir, in the precision landing, we are making sure that there is no shadow artifacts.
Okay.
So if it's been taken from a central position,
Yeah.
a rock may cast a shadow like of the LiDAR
Okay.
onto this spot, and the center may not be perfect.
Okay.
So we
So,
go
so
to
this
that.
texture is okay for you? Whatever the textured thing is?
Yeah, it's fine. But if there were some bigger obstacles, then it would be a problem. So we are taking the precision scans.
Okay.
Right now, the precision scans failed because we considered the maximum height of an obstacle to be 1 meter. So it was detecting this wall
Okay.
and considering this to be an obstacle. So
Okay.
the rest were scaled down to match it. So the data is normalized in many steps.
Okay.
So compared to this, all of the other rocks were not very large. So they weren't detected as big obstacles.
Okay. Thank you.
So in the central one, we didn't detect this edge because it was far away. So the scan succeeded.
Okay. Okay. Thank you.
Thank you.
Rushikesh, we can continue the run.
Okay.
Ready? Orientation check. Calibrating level. Okay. Calibrating level. Rebooting compass. Okay. Mode. Mode stabilize. Stabilize. Yes. Okay. That's all. Connected.
Setting the height at 2.5. 1, 2, 3.
The drone has taken off. Going to the first corner. Detected. Reach the first point for scanning. Toshit, are the coordinates visible?
No, actually.
Okay, okay. The spot is detected, it is landing autonomously.
Okay.
And there was no manual intervention at all.
Will arm again. Arming.
It is taking a precision scan at the third spot.
Detected and correct. Landing. Till arm again.
Now it is returning back to home.
Okay.
Actually, the home spot was approximately detected. That's why Aryan had to take a little bit control while landing on the home spot at the end.
Very good, excellent. And after stopping at that point, it was automatically trying to take off after the first spot. Arming, you were telling arming, it's autonomous.
Yes.
Okay, no, just for as per plan, it was autonomously taking off. Very good,
Yes, sir.
excellent.
Everything
excellent.
was autonomous.
Very good, nice. Only
So
very good. They say third spot it could not identify the slant one, or what was the reason?
Sir, we'll check the logs. Are we allowed to restart? Just one more run?
Just one more run to verify.
One last one.
Okay, good.
Thank you so much.
I just took the controls while it was landing because it wasn't able to detect the landing spot, the home spot correctly. Otherwise, everything was autonomous. I was just here to take landing. At the time of landing, you just at the home spot, not at the any other spots.
So
Everything was autonomous.
landing is not manual, autonomous. Right from
Only
from everywhere it's autonomous.
Only for the home spot, it was manual.
Oh, last home position was manual.
Yeah, the last one.
Okay.
Other than that, the safe spots, it was automatic.
Okay, fine, fine.
I mean, I can do anything with it manually, but like that is only for safety. Like if it loses control, then I have to take control of it, which it didn't. Oh, okay. If
No,
you
no.
want, I can like hold the control like this.
No, there is no gyroscope sensor in the remote.
I was trying to show you that I'm not using it. If you want, I can hold the
Just trying to show you that is not controlling.
Yeah.
Yeah, only one part was manual. Actually, the last home spot coordinate was not exact. That's why he took it manual. Otherwise, all the landing and all the takeoffs were autonomous.
It has gone to the home spot, but on the landing time you have intervened. Return to home spot was correct.
Yes, it was correct.
How much time will you take to do it again? You were telling, no, you want 5 minutes.
We have an extra
We
battery.
all
there
are
are
trained.
scans. There are scans. If you want. Are scans
You might have
visible?
to change the battery, is it?
So this is the main scan. Once again, it detected all the three safe spots in the first scan. And this is the purple dot which denotes the position of the drone while scanning.
With the battery, we are doing a return to home as we did right now, but it is not very precise. Again, we can demonstrate it. We can show it now.
We can show it to you.
There is no dead battery
नहीं नहीं है ना अभी अभी की depleted
We have a depleted battery, so
we can increase the threshold voltage to show the fail safe like yes sir it will go to 0 0 and land as it did for both battery
If
and
you can demonstrate that also is fine.
yes sir we'll do
The link failure you will demonstrate or battery failure, one of them will demonstrate.
both of one of them
That's okay.
so this
In
one
case
was
spot, if you have to
detected
do, it may take some time, no?
The same run we have to repeat it once.
Yeah, because okay, for doing that repeat, how much time it take for you? 5 to 10 minutes.
just right now it's ready right now we can
Battery.
we can swap it out right now yes sir.
Okay, sir. Should we give
The
them a
problem
chance?
with this spot was it was
One more chance
detected to
they're
be
asking.
outside of the arena.
Okay. Oh, okay, quickly.
It has detected,
Quickly
but
can
it is
go
said
for
it
the
is outside the arena.
next attempt. We go for the one more attempt now.
Yes.
The last attempt.
Okay.
Yeah. Yeah.
We will
Go
set
ahead.
the threshold to be closer to the arena. Yes, sir. Yes, sir.
Good. Good. No problem. It's not bad.
Okay. Actually, just 2 minutes. He's changing the code a little bit. Meanwhile, I will tell a few points more. During the last round, the scientists visit, they suggested us some improvements, like there is not a perfect magnetic field on Mars like on Earth. So we were initially using a magnetometer. So they suggested not to use it. So I have disabled the magnetometer, internal and external as well. We are only using the internal IMU combined with the camera feed which tells the yaw of the drone. So that is one point. Another point is that initially we did not consider that the home's safe spots can be elevated. So we have imbibed that as well. And yes. Yes. Actually, we are not fixing the initial yaw because, yeah. Actually, we are not able to control the yaw perfectly. We have tested it, but the drone. Yes, so we have not allowed it to. Uh, yes. Yeah, we are not doing that. Yes, sir. Yes. Hmm. Outside. Yeah. Yeah, yeah, yeah. Yes.
Lunch has arrived. Anyone wish to, other than, I mean, our expert panel, anyone wish to take, they can continue. They can go ahead. With lunch has arrived, sir. Arrived.
Next teams can go for lunch and be ready.
We have informed them. Yes, sir.
Good. That's
The incline one. Actually, it was on the edge. It was on the edge of the arena, so it considered it as like outer part. Yeah. The home position. Actually, because the area of the home position is comparatively smaller than the other spots. So when the scan is done, it is at the center, and that position is like the farthest one. So it also reduces the size a little bit. Yes, actually. Yes, for that reason we are doing the precision scan. We have made a little bit wider range of areas for detecting it as a safe spot. So it was detected, and after going there, it also takes a precision scan. So it consider it as safe. Yes. Actually, we did not take precision scan after return to home. That's why it was not precise. So as you can see, this is the web interface that we have created. So it shows all the telemetry X, Y, Z, your battery status, power delivery of in ampere and wattage and everything. And also the maps which are detected are displayed on this web interface.
तिकडेच थांब म्हणजे बोलता येईल मला. Okay. Okay, let's start. Modes change, RC. Can you change the modes, Aryan? Stabilize.
I just wanted to ask, like, how do you want me to hold it? Like, if you want a verification. Yeah.
Maybe you are also moving along with it, but we got a doubt.
I just wanted to, like, yeah, show us, show you guys that I was using it.
Okay. बंद करून टाका तुझं. Level has been calibrated, rebooted.
You can also announce what you are going to demonstrate, because you are told only you are planning the inclined drop.
So now we are going to have it go to the inclined spot first by moving it closer to that spot. So after it detects the corner, we'll move it in this direction more. So it will first go to the inclined spot.
So how did you feed that input? Go only to that like that? No. How did you select
so
it?
we changed the code right now to make it go more towards this side.
Oh.
So whenever it sees some spots, it goes to the nearest one.
Okay.
So it will hopefully go to the
Okay,
slanted.
starting scan favor to that point.
No, heading is the same. The displacement from the corner is different.
Okay, let's start.
At 2.5. 1, 2, 3, start. The drone is armed.
As you can see, the live telemetry data is being displayed on the screen as well.
So here we have kept it more biased towards the slanted spot. So it should detect it first. Telemetry lost हो गया. There is a telemetry loss signal here.
Okay.
Okay, so this was the telemetry test.
Okay, okay. Oh, that was planned for a telemetry loss test?
I don't think
Yes.
No, it was not planned,
Okay,
but I
okay.
can show you the messages here.
Okay, go ahead, go ahead.
It was not
Thanks.
planned.
Okay, fine.
Okay, sir.
This time also I took a little bit of control just to make sure that it doesn't fall over. We'll try to do it again without the data link loss. Sorry for the inconvenience, guys.
You can see the messages. Should I put it in front of the camera? Here you can see there are the telemetry lost messages. So it was disconnected from the ground station which we were viewing here before.
It is visible.
Okay. Let's restart.
Actually, the battery voltage right now is 11.57 and the threshold we have set it to is 11.5. So in like under a minute, it would attempt a battery failsafe right now. Yes.
Change the battery and do that, but then battery fails safe. Okay, now battery fails safe must be.
Yes, battery failsafe.
Okay. Don't you set the position? Orientation check. Okay? Okay.
So the battery failsafe threshold is set to 11.3 volts.
Okay.
Starting in 3, 2, 1, start. So almost immediately you can see here the battery dropped to 11.19 and it has
Actually, as soon as it took off, the battery failsafe got activated. So it did not get any time.
So in the battery failsafe, we do not do a precision scan because there is not enough time. So it was not very precise.
By the way, the home spot is 1.2 by 1.2, right? Yeah, that is the only reason I always have to take controls there because we have programmed it to only detect areas of 1.5 by 1.2. So in these one, I didn't take control. Like if that was 1.5 by 1.5, it would happen.
Sir, we are really sorry, but just because of the
Kaushal?
telemetry failsafe, we could not demonstrate the inclined flat spot detection.
It will take 2 minutes. It's already
Just 2 minutes. Everything is charged and ready. Really sorry for the inconvenience, sir.
Kaushal, we'll change the battery, okay? Dhaval is bringing.
Just connect the battery first before securing it. Connect it first.
Is battery connected?
Yes.
Okay. मिशन पे ऑन करता है मिशन पे ऑन कर आणि लेवल कॅलिब्रेट कर लेवल पिक्सल थांब खतरनाक हो जाएगा हो गया Orientation check.
5 minutes.
Battery is connected.
Okay. Orientation check.
Check.
Calibrating level. Rebooting compass. Showing telemetry. Okay, loiter. Three, two, one, start.
Line detected. Now going to a position which is slightly near the inclined spot.
Detected incline.
Taking a precision scan. Coordinate detected.
Detected.
Landing on the incline spot.
Yes, it will reach.
Perfect position.
Reach. Landed.
Landed perfectly.
Let's go. It will take off again. It will take off again. Okay. Arming. Fine. Okay, so I think it is finding the next corner.
It has detected the corner.
Detected another spot.
As we can see, the new scan is detected.
Okay. Landing. Okay. Kill it.
Aryan, you can kill it now. We have demonstrated what we had to. Sir, shall we continue? To the last spot?
It can scan last spot also.
How is it programmed now? Is it going?
It will continue
Yeah,
as it
go ahead,
is.
go ahead.
It will continue.
Yeah,
Okay. Taking off, arming.
Now it is taking a precision scan over the third safe spot, which is the last one.
New scan detected. Landing. Land.
Are you continuing again?
You can kill it, Aryan.
You can
now.
kill it now.
All the spots are covered.
Yes, all spots are covered.
Okay, that's it. Okay, excellent. Very good.
Also about the incline spot, the drone might topple sometimes on the while landing on the incline spot. So we have added rubber pads under the feet of the drone so that it has maximum grip and it does not slip down.
Okay, okay.
You can take a closer look at the drone. We have brought it here.
Over here we've used an S500 frame which is 500 millimeters in diameter. We've used the Raspberry Pi 5 as our processor and Pixox 6X Mini as the primary flight controller, an ESP32 for telemetry, a separate buck and as a power module for powering the Pixox, and the buck powers the Raspberry Pi as well as the micro servo which basically turns the LiDAR from minus X degrees to X degrees, which facilitates in the map generation and scanning.
Kaushal, also mention about the self-made damper we have used.
Yes. So we found out that the below is the damper, which has the Raspberry Pi camera, the wide-angle camera module 3, which is completely isolated from the upper section. So this damper, we found out about it because stainless steel threaded wires have maximum friction absorbing capacity, so that they absorb the vibrations from the damper. Hence, we get a clear field view of the ground. Yes.
It isolates the camera from the drone and reduces the vibrations significantly.
Damper as well as absorber, which is right. Then what is the frequency beyond which it will damp?
Actually, we have not measured the frequency. We have taken multiple trials on. Yes. Yeah.
Experimentally viewed each footage starting from.
So its camera stability is very good because of this.
No, that see this innovation in scanning. What is that innovation in the scanning? That what is the algorithm here? Innovation.
So we try to minimize the cost of our system, which only uses a low cost, which is 6,000 rupee 2D LiDAR and a cheap servo. And it still yields us a 2.5D map. Which
How are you calling it a 2.5 map?
So, as I said, the servo scans a slice of a 3D space because it has a rotating servo mount inside. So it captures points in a plane. So we take the LiDAR and we rotate it along an axis so that the plane sweeps across the surface.
Okay, what is the angle? It is sweeping angle that.
So right now we've set it 120 degrees. So
120 degrees.
Plus 60 to minus 60 degrees.
Okay, any that outliers? How you have removed that LiDAR outliers? No,
yes, sir.
How
so
did you do that?
To remove that, yes. So in our specification of the arena, it was given the size of the obstacles would be less than 2.5 feet.
Okay.
So we cut off any points above
threshold
that.
cutoff. That threshold cutoff. Threshold cutoff only you have done
yes.
that. You have not used any filters.
No. After that, we are using filters.
What is that filter?
We use a filter. I don't think it has a name. I call it variance. Basically, for each pixel, it takes a square around the pixel and computes the maximum and a minimum value and takes their subtraction. So it gives a measure of how fast the surface is changing.
Can you tell that what is the critical part in the entire thing? What is the critical part?
The critical part is localization, sir.
Localization.
If it does not work.
Fusion. Okay, you have to explain actually that dots, all those things you have to explain your localization. Oh, correct.
So this was of the first run, which failed sadly. But so here you can see the green points are being tracked across the surface. Yes.
Optical flow.
Optical flow, yes, sir. And you see the magnitude vector points opposite to any yellow pixels.
Okay.
So it allows us to go away from the border.
But what is the maximum speed it will go such that your optical flow is perfect? Anything limitation is there?
So we have set a limit of 30 centimeter per second. So
Yeah,
in this
that-
whole run, it was.
Okay, but you can test with the higher speeds also. That
We have
optical flow.
tested with 50, but it crashed.
Okay.
So
What is your that data rate? Here this optical data rate.
the data rate of the camera is 120 FPS, but the
FPS.
Raspberry Pi is not able to process at that
Yeah,
speed.
correct. That's why I'm asking that question. What you are sampling that?
So we are doing it as fast as the Raspberry Pi can.
Okay,
It is
right.
not set at a specific rate.
Okay, yeah, all data you are storing in that memory. How you are managing the storage in this one?
So this video we are simply writing it to a file,
Okay.
but we were unable to manage it because that's why it crashed here.
That you are having the NVIDIA here. That
No,
processor.
sir.
What is
Raspberry
it?
Pi.
Raspberry Pi.
Pure Raspberry Pi.
Okay, but computational will be expensive, no? That.
Yes, sir. We thought of using an AI module, but
Okay.
it didn't work out.
Okay,
We were
good,
unable
very
to
good
use it.
one. Yeah.
Thank you, sir.
Fully autonomous. Fully autonomous.
With the Raspberry Pi, sir. Yes, sir. It consumes about 4 amperes. Yes, sir. So we have 3 batteries, sir. So we kept charging them. Yes. Yes, we are changing and charging them.
We have seen that with one battery we can have the lifetime of around 7 to 8 minutes.
We have actually made all the mounts using 3D printed of PLA material. That is why it is very lightweight. And the frame also has carbon fiber forged rod. After that,
So the LiDAR is rated for 12 meters, but that is electric power. I'm not sure, sir. I'll have to check. But by far the Raspberry Pi is the most power hungry element of it.
One question you can just yeah, just
Technology, what are the other novel things in this? All these things have been
No, sir, we haven't done. We have cut down on weight.
Okay, fine.
All the 3D printed.
The battery tries to go to home, but it is usually incorrect, so it lands there without taking.
Initial stuff is what you have taken. What are the other things that you have built over there?
Yes, other things are the 3D prints we have built over that. This is the Pixoc casing which protected it during the first fall. One broke and this is the second one casing. This is the Raspberry Pi casing. The most novelty we have is the damper which we are using, which basically isolates the pi.
Our college doesn't have any mechanical branch.
So we are only researching
We did some little research on it
And the CAD design was done by me and me.
the most unique selling point that we have is the lack of a magnetometer.
Yes.
You have done the stress analysis?
Actually, we tried
A
some
stress
material.
analysis was also experimental.
We tried
So we did not do stress analysis.
50%, 70%, which are
What
the 3D
condition
prints.
this particular thing acts as a protection device?
right
When
now
the drone
drone
flips
fell off
and
upside down. That time this wing broke
This
off.
particular thing will get damaged.
Sometimes the obstacle may be like this in the shape and it melts.
So it is only, it depends on the shape of the obstacle.
Yeah. So why take a chance? Keep it safe.
Throughout the multiple months that we have tested it, this generally doesn't break, but the Pixoc is very important so that way it needs a quick protection.
Can you just identify the different sensors? This is one thing which is clear. It is a camera, which is your depth camera.
We are not using
we are not using a depth camera.
And is this your optical flow sensor?
This is a simple camera, Raspberry Pi camera.
And the
This is the
optical
1D
flow
LiDAR
algorithm
which
is
we are
custom.
using as the primary rangefinder for the
This is the
drone.
1D LiDAR and this is the
2D.
Yes, sir.